Um, we're going to go over some Ajax examples today, and a couple things as far as housekeeping goes and sort of background information. This is the last lecture we will have in this class. Next week is sort of a week for you to wrap up all your assignments, to ask any questions that you have about any of the outstanding assignments. I will be having extended office hours. I will post something about those later on this week, so be on the lookout for that. We're winding down here at the end of the semester, so it's time to get things wrapped up. I am generally very flexible about due dates, but at the end of the semester, I have to make a strict deadline. So I will do that. Another thing I just noticed is that I had enabled the rest of semester module, but I forgot to enable to do rest of semester, and I apologize for that. If you look at that, that has good information about setting up a database in MySQL. So if you've been having trouble with that at all, if you've attempted it, or if you have not attempted it yet, take a look at this document. All right, your last assignment is to do Ajax and to convert lab 9 to 10 to do the calculation as a Ajax request instead of a traditional request for a PHP page. And what I mean is something like this, and we reviewed this example last time, but we'll re-review it today. There are, by the way, 3 Ajax examples, and one of the examples has 3 versions. So there's several Ajax examples in here. There's the first one that we went over last time. There is a Ajax quiz that we'll spend some time about today, and there's a dictionary webpage that we'll go over today as well. Let's look at the first one, though, that we went over last time as a chance to review sort of the Ajax concepts that we had covered. Let me extract that, and I'll put it in my web server's root directory, which is CINetPub www root. And what I did is I took and I did 2 different versions of Ajax, and let's talk about how they work. One I used with jQuery, one without jQuery. So we pull up the web server. Okay, why is it not bringing it up? You're just going to type in the IP address. Let's see if that fares any better. There we go. I did the calculator through Ajax. And if you notice, what that happens is I type in and I click that, and it happens without reloading the page. As you know, in the traditional calculator, if we enter in the data, it reloads the page, or it goes to another page, or reloads the same page. With the Ajax calculator, it does a calculation without having to reload the page. So let's look how we make that work. I'll be skipping the validation just to go to the Ajax part. We'll assume the form is valid. It makes the Ajax call. To set things up, we create a request object, and we create that object outside of any function, so it's available across functions. So that's the function that does it. When we make the Ajax call, we define a URL, which is the name of the server-side script that we want to call, followed by the items on the query string that we want. And again, we can write this out to the console to see the exact value of it by doing this. This is a valid debugging tool because you are a valuable debugging tool. It's definitely valid, but it's valuable as well because this allows us to see exactly what gets called when we make the request. In case it wasn't working, we can see exactly what gets called and make sure that what we're calling is the script that we ought to be calling. And right there, it shows the name of the script that we called, and everything's formatted correctly. Question mark, first field equals value, and ampersand, second field equals value. We can go and test this further to make sure things are going correct by just copying and pasting this into the address bar and making sure it gives the right value. And sure enough, it does. So that's a couple things that you can do to test it. Make sure you're calling the right URL. Make sure that URL gives the proper value when you call it. So anyhow, looking at the code for this, we define a URL. We open that URL, that's opening the pipeline. We give a callback function. What the callback function is the function, the JavaScript function is going to get called when the server is done processing this request that we're going to make. And here we're actually making the request. So we make the request, we call the server-side script, which is which one is it? Check range Ajax? Yeah. It does the validation, includes the other function, and returns the value. All the work is done in these functions, so we're still using the functions that we defined way back at the beginning of this. And then, when the server is done with this thing, the ready state will be 4. This gets called every time the ready state changes. The only one we're interested in, though, is step number 4, where, or status number 4, where that indicates that the server is done processing, and we can take the response text that the server gives and put it in the HTML in the results. You'll do something very similar to this for last assignment, except you'll do it with the tuition calculation. All right, now let's look at these other examples. These other examples are in a way a little more elaborate, but I think it's important to see that we can do more than just this very simplistic one. Let me extract this one, and let me copy over these into our server. This is a quiz. Where we put in the numbers and we put in the answers. Let's get some right and some wrong. And when we click grade, it goes and it grades us. In this case, it gives us, we got 75%. I didn't spend tons of time formatting this. You should do so on your assignment. I can't emphasize this enough. I try to keep my examples stripped to the essentials. That doesn't mean that you can do very bare bones homework assignments though. All right, let's look to see how this works. This is a little more involved because what I do is I use, in creating the quiz, I use PHP to create the quiz. I loop through these two arrays to create my addition problems. And those two arrays are in my include file. Again, as I mentioned last time, I've since learned from this that include files should not end in INC, but are better to end in PHP. That's not what I wanted. Oh, yes, it is. This consists of two arrays. All right, and these two arrays allow us to loop through those two arrays and generate the questions. And we're creating a text box each time through the loop that gets numbered with answer and the value of I in the loop. So if there's 4 questions, the text boxes will be labeled answer 0 through 4. And creating it. When we click the button to do this, we go and do our Ajax request. We've created our request object. We grab a hidden form field that tells me how many elements are not a hidden form field. I'm sorry. We grab the size of the array to let us know how many are in there. This, by the way, is a mix of PHP and JavaScript. That's pretty advanced. If we didn't do this, we would have to hard code the number of questions here. But here we're able to create a value, and this occurs again when the page is originally loaded. So we're going to put into this snippet of JavaScript the number of elements in the array. We then loop through and form our URL by tacking on answer plus the value of I plus the value of corresponding text box. So if we did our URL here, I'll put an alert here. We get the URL of this. Grade.php answer 0 equals 6, answer 1 equals 12, and so on, which corresponds to the numbers we've added. We then call our server-side script, which is called grade.php. And it includes the questions so that we could calculate the answers. Remember, questions is simply an array of the first number in the addition problem and the second number. We loop through, we grab the answer from the query string that the user entered, we calculate the correct answer, and we output a Y if it's correct, and an N if it is incorrect. We do this for every question in that array. So when we're done, we have a string of Y's and N's. Let's take a look at that. And again, I can see exactly what the script returns by copying it and adding it in the address bar. And you notice we get a series of Y's or N's, indicating if the questions were right. I got all the questions right, so I got 4 N's, or 4 Y's rather. So this comes back to the client side in our handle response, and we get back, we can see the response that we get to make sure it's the response that we're expecting by doing an alert there. Here I'll put some wrong answers in, or all wrong answers in. I click grade. That's the URL that gets called. This is the string that we get back, 4 N's, because all of these are incorrect. Then loop through our responses. We split our response text using a comma. Whenever you have data where different fields are separated by a special character, in this case a comma, it's called delimited data. In other words, the comma or the tab or whatever separates individual values that are part of the string. Well, here we split it using a comma because we know we used a comma to separate our answers on the query string. And then we loop through and see how many Y's and how many N's we have. If we have a Y, we add 1 to the correct. Either way, we add 1 to the number of questions, and therefore we can calculate the percentage correct and display it. Now, in your example doesn't need to be this involved. I did want to show an example, though, where delimited data was used. And I did want to show an example of how we can make everything data-driven. In other words, if I want to make an extra question on here, I just add a piece of data to this, and everything is taken care of. And that ought to be your goal for maintainability. %20. Whereas we only need to make the change to one place to add an addition problem. Now, if we want to add multiplication and subtraction problems, we could do that too, but would have to add another array here to indicate which operation. I kept it simple and just did all addition problems. But again, notice we're following the same model. We create our request object. same way we did in the other example. We create our request by giving the URL of the server-side script that we want to call, and we concatenate onto that any data that we want to pass to the server-side script. And we make the call and we give the callback function being the JavaScript function that's going to process the data. And the JavaScript function that processes the data is going to take response text and do something with it. Here we're taking it and we're splitting it using a comma. What that will do is that will create an array called results that has as many elements as there are things separated by commas. We then loop through that array and count the number of Ys, and that gives us how many correct. I know I'm going through these pretty quickly. Please go through these on your own time. Remember, this is a blended class, and therefore you're expected to spend time out of class going over the online resources that I provide. And please ask any questions that you have about this. The last example that we have is one that we actually have several different versions of. And this represents 3 of the ways that you can pass the data back to the client. Hint, hint. The limited data or just simple data will work for you in this assignment. However, on the final exam, you're likely to be asked questions about delimited data and XML and JSON. So this is important to learn as far as the grade in this class goes. So we're going to look at the first one under delimited. We're going to go delimited, JSON, and then Ajax. So I'm going to go and access by local server. File called dictionary. I have my original page with the form just being an HTML file. Could very well be a PHP file. All right. Here we click, this is a translation between English and Spanish or mathematical terms. So if I start typing the terms here, I get a list of English mathematical terms that start with A. If I type in the next letter, it narrows it down to find the English terms that start with AX. I pick one, click this, and it will show me the Spanish translation for it. This is similar functionality to what we see in Google, right? Whereas if we type in something here, it shows the top 10 suggestions for it. Now, this is obviously a much bigger example. It involves scanning the Google databases, and it's always going to find 10 suggestions. Here, we only find as many as there are in the dictionary. And it's not stored in a database, all right? But it's stored in arrays. There's actually 2 Ajax requests here. The first Ajax request is made when I type something in this character. Let's type in a character in this text box. The second is when I press the button. Okay, let's look at this, and this, and this, and this. All right, let's look at our, first of all, our dictionary HTML file. We actually create two HTTP request objects because we have two different Ajax requests. The one to give us a list of the English mathematical terms that start with whatever we typed into the text box. And the second to give us our actual final answer. So when I type one character at a time, I'm using a different event that I've used so far. I'm using on key up. There's actually code that you can execute when you press a key down or when you press a key up. We want press a key up because the text in the text name is only entered when you release the key. So every time we type in a key and release the key, get words gets called and it passes the value that is in the text box, which is the characters we've typed so far. First thing we do is if there's anything typed in, we get rid of everything in the drop down. So if I start typing in an A, the first thing I do is I clear out the whole drop down. Oh, I'm sorry, the other way, my mistake. If there's nothing in here, then I clear out the drop down. That's what this means. If the arguments enter space or there's a space inside of it. We could probably do better with that using the trim. Otherwise, we open the request, dictionary.php question, word equals the argument entered. What is arg entered? Remember, it's the value of that text box when we release the key. On ready state change, we call create DD, and then we make the request happen. On create DD, if there is a ready state of 4, we grab the response, which is an array. It's actually an array that's split two different ways. It's split with colons between each entry and semicolons between the number of the entry it is in the array and the entry in the array. Let's look at the include file. We have a giant array for the English words. We have a giant array for the Spanish words. So if we typed in an A, it will select all these words that start with an A, and it will return the position in the array. So this one has a value of 0, 1, 2, and so on, followed by the term. Let me show you what that is by putting in, by rather calling the server-side script. I typed in A, for example, it will give me this. Each word is separated from each other word by a colon. The word is separated from the index of the array by a semicolon. So we're going to use the split command twice. One to split these down into separate words. One is to split it apart, the name of the word or the word itself, followed by the index. That's exactly what we do. We first split by colon. We then loop through for each word. We split by semicolon, and we create a new option for the dropdown, creating a value of the index of the element, or containing the name as the text of the option and the number as the value of the option. When the user clicks the Get Translation button, what happens? We get the value. It's a different way to get the value of this. We get the value of the selected item in the dropdown. If the value is -1, that indicates that no word was picked. And then we call dictionary 2 and pass the index. So if, for example, we picked absolute value, the index would be 0 and would get back the translation for absolute value. And we simply display that on the screen. Now, the other examples, the other versions of this behave the exact same way. The only difference is how we are going to split the list of words that are returned. In the JSON example, the data comes back as JSON data, which stands for JavaScript Object Notation. Let's take a look at that. You see, it behaves the same way. The only difference is how it pulls back the request from the server. So what I'm going to do is I'm going to call dictionary 1. And give in the word of A. We get back data this way. We get back something that's called a word list. This word list is an array. Each entry of the array is contained a piece of data that contains a word and an index. Notice how these are separated. The word is separated from the value of word by a colon. That pair is separated from any subsequent pair by a comma. Now, in the first example, I could use semicolon and comma. I pick those. In this case, this is how JavaScript notation always works. So this is what we're getting back in response text. How do we split that up? We split that up using dot notations. First of all, we create a JavaScript object by transforming the response text into a JavaScript object. We loop through the array that is word list, because word list is defined as an array, and we use word lists of I as from wordless sub I, get the word, get the index. So whatever value this is, the first time through it will be 0. We get the word, which is this, and the index, which is this. Now, when would you use one versus the other? Delimited data is used generally when the data is very, very simple. So when we did the heart rate calculation, we were just returning a string that said they're in the heart range or they're not in the heart range. That's all we needed to do. So for that, we might as well use delimited data. In fact, that wasn't even delimited data because we were just returning one piece of data. For something more involved like this, where there's actually different fields associated with each word that's returned, the name of the word and the index, something more involved like either JSON or XML might be better. Finally, if we look at the XML version, we get an XML data, which is kind of like HTML, but it's user-defined HTML-like code, where we have a word list that contains items. Each item consists of a word and an index. It's much easier to represent a data structure that's more involved using XML or JSON compared to delimited data. You can do it, but it's not quite as easy. And then what we do is we have our code that processes that. This way. We get an array of item elements from our XML file. We loop through those and we grab the word part and the index part from that. It's most important to understand when you will use these. As I mentioned, you will use just very simple single value / delimited in your homework assignment. But it is good to know why you use these. For simple data, delimited is the way to go. For more complex data, JSON or XML is better. JSON is a little less resource intensive than XML because with XML you have a lot of extra characters. With JSON you only have a few extra characters of data. So both JSON and XML represent a way of encoding data structures where you have related data and all that. You could, for example, create an XML file that showed a book, and the book could have multiple authors, and it could have a different formats like paperback and hardcover and so on. That would be very difficult to represent in a delimited data, but in JSON and XML, it would be possible to do. JSON being a little leaner than XML, but XML offering more fully featured. All right. Remember, there is no lecture next week. There will be extended office hours. Please pay attention to the announcements because I will describe that in the announcements. That's all I had today. I hope to see you in lab if you're having questions. If not, we will see you later. Take care.